through adding, subtracting, and multiplying decimals. Engage New York and all of their wisdom for us to be able to add decimals gives us mixed numbers. Love this system so much. It's really awesome. Yes, that is sarcasm, for those of you not picking it up. So our first step is actually going to be turning our mixed numbers into decimals. So in some ways we are just kind of reviewing because we have already done this, which I hope is why they did this, to help make sure you guys understand how to do that. The easy way is if my denominator is in a multiple of 10, 10, 100, 1,000, makes it very easy because whatever's on top becomes my decimal place. So if I can quickly get to a 10, 100, 1,000, you can do that, or we can do it the old-fashioned way, which is just dividing the number out. So the first thing we're going to do is actually convert our mixed numbers into decimals, and then we will do the adding or subtracting. So our first one, it's easier if you say it. It'll help you write the decimal. So if I said this mixed number, how would I say that one? 25 and 3/10. So now if I write it as a decimal, I write it as 25 and 3/10. Make sense? Everybody good on that? Okay. In this case, I'm adding. And how would I say the next number? I think, Liam. Close. That's the decimal part. How would I say the whole number? Good. So I just write it 376 and 77 hundredths. Okay? What is the rule for adding or subtracting decimals? What is it I need to do first? Solo? What about it? Move it where? What do you mean by move the decimal point? Devin?
You need to make sure they're in the same place value.
Okay. I'm going to interpret what you said as line your decimals up. Okay? In order to do this, so adding or subtracting, and add this to your notes up here. So to add or subtract decimals, our big focus, line up the decimal places. So this is your big rule takeaway for adding and subtracting, guys. I have to line up the decimal places. Okay? So, in other words, I'm going to write them on top of each other, and I'm just going to say, make sure my decimal place lines up. So if it helps you, write that decimal place in first, and then rewrite the number around it. So it's 25 and 3/10. It is really important that you have good handwriting and that you line everything up. Keep them in very straight lines. Now, for those of you who struggle a little bit on your handwriting, you may also add a 0 here. You don't have to. If you realize that a blank space is a 0 and I'm just bringing that number down, you can do that. But for most of you, it'll probably help to actually physically see that 0 there. Once I have them all written down and they're all lined up, now I just add up the rows. So I do 7 and 0 is 7. 7 and 3 is 10. And just like usual, I just carry that 1. Here's the big difference. For my answer, my decimal just comes straight down. So I'm going to go ahead and put that decimal right now into my answer because it's coming straight down. Then I do 6 and 5 is 11 plus 1 is 12. 7 and 2 is 10. 9 plus 1 is 10. 1 and 3 is 4. So the answer is 402 and 7/100. Yes? I hope so. Good. Like I said, this should be a review, but this year especially, we're not taking chances. We want to make sure that everybody understands what it is you're supposed to be doing. Okay? Now, our next one, they threw a little more of a challenge because they didn't give us easy 10s, right? Or they didn't give us 10s. But is it easy to go from 1/5 to 10? What would I do? Times 2. So that gives me 2/10. Now, if you don't see an easy way, or you don't like doing that, you can also just divide them, guys. I can take 1 divided by 5. That's going to give 2 times. So, mathematically, I know it's 2/10. Or as a fraction, I can say it as 2/10. But either way, when I now convert it to a decimal, that's going to be 426 and 2/10. Okay? Then I'm going to subtract 275. What is 1/2 as a decimal? I can multiply both those by 5 to get it to 10. So it would be 5/10. Everybody good so far? Okay. Our rule for subtracting is the exact same. We do have one slight difference though. Up here on the addition, it didn't matter which one I wrote underneath the other one, because we have what's called the commutative property of addition. I can add in any direction, right? Subtraction, though, I have to make sure that the second number goes underneath the first number. So I'm going to have to subtract, make sure, again, are my decimal places line up, and I'm going to build the rest of the number around the decimal places. Okay? From here, now we just do our regular math. Can I do 2 minus 5? Nope, so I'm going to have to borrow. So 12 minus 5 gives me a 7, just like with addition. Once my decimal places are lined up, my decimal places come straight down from my answer. Then I do my next one. 5 minus 5 is 0. Can't do 2 minus 7, so I'll borrow again. 12 minus 7 is 5. 3 minus 2 is 1. So 150 and 7/10. Is everybody okay on these? Okay, I hope so, because now's your chance to prove it. So we'll let you guys do the rest of these on your own. Yes? Because it said to subtract. Because if you look at the signs, right here, it says add. Right here, it says subtract. So you have to do what the problem tells you. There it says add, there it says subtract. Okay? Now, on the word problems, you're going to be needing to make a judgment on which one you're doing, adding or subtracting. But go ahead and go through those, and we'll go over them together in about 5 minutes. Okay, so let's take a look at this. Samantha and her friends are going on a road trip. It's 247 and 7/50 miles long. They've already there we go. Driven 128 and 53/100. How much farther do they have to drive? So this is going to be what kind of a problem? Subtraction problem. Our first one's relatively easy, 7/50. I can make that and 100 really easy. So that's 14/100. 53 is already in hundredths, so I'm going to do 245 and 14/100 minus 128 and 53/100. Again, our rule is line them up. Okay? You hear that? So 4 minus 3 is 1. 11 minus 5 is 6. My decimal comes straight down. Can't do that one, so I'm going to borrow again. That gives me a 6. 3 minus 2 is 1. 2 minus 1 is 1. So they have 116 and 61/100 miles to go. Are we good on that one? Okay. Number 2, he needs to replace 2 sides of his fence. One side is 367 and 900 meters long. The other, 329 and 3/10 meters long. How much fence does he need to buy? This is going to be what type of problem? Addition. Good. So the first one they gave me, pretty simple, 367 and 900. Make sure you put the 0 in there because it's 900. And I'm adding 329 and 3/10. Doesn't really matter which way I go on this, so I'm just going to go underneath the first one. Again, make sure you line up your decimals. If you need to, add that last 0 to make sure you've got all your places lined up. 9 and 0 is 9, 0 and 3 is 3. My decimal comes straight down. 7 and 9 is 6. 18, carry the 1. 8 and 1 is 9. 3 and 3 is 6. So he needs 696 and 39/100 meters of fence. Number 3, wants to paint his office with 2 different colors. He needs 4 4/5 gallons of red and 3 1/10 gallons of brown. How much paint does he need in total? So the only one we really need to switch is the 4/5. That's easy to make tenths. Go by 2. So we have 8 tenths. So if I write that, it's 4 and 8 tenths. What's my operation on this one? Adding, because I'm putting them together. My second one, 3 and 1/10, basically just saying it tells me what it is. So add, just line them up. 8 and 1 is 9. My decimal comes straight down. 4 and 3 is 7. So he needs 7 and 9/10 gallons of paint. Any questions so far, guys? Okay, looking good. Let's go to the next page. After I completed this work, she figured she still had 78 and 21/100 pictures to paint, and she completed another 3 and 23/25 pictures. So how many pictures does she still have to paint? So what kind of problem is this one going to be? Subtraction, good. My first one, relatively easy, 78 and 21/100. 78 and 21/100. My second one, I need to do a conversion, all right? So 23/25, I know I can go to 100. Multiply both by 4 gives me 92. Then I just put the whole number in front of it, so I subtract 34 and 92/100. Everybody tracking so far? Okay. Now that I'm subtracting, the 78 has to come first. So from here I subtract the 92/100. Again, we're borrowing all over the place. 11 minus 2 is 9. Borrow again. 11 minus 9 is 2. My decimal comes straight down. 7 minus 4 is 3. 7 minus 3 is 4. So she has 43 and 29/100 pictures to paint. Then number 5 you didn't have to do because the numbers don't work out well. We end up with repeating decimals. So don't stress on those two. Questions on any of these? Okay, guys, turn real quick to your next page. Unfortunately, I don't have it on here yet. So I'll probably add it before we finish up the recording. But on this page, you're only doing number 1, parts A through E. Don't worry about number 2. You can just cross that out. We're not going to use calculators. I'm not going to stretch you guys out on the ones that have repeating decimals. Okay? So number 1, A through E. Remember, go to hundreds, tenths, thousandths. Make sure your math is easy on those. Okay, first thing we're going to do is we're going to multiply these two numbers. So 51 times 2, all I need to do, 51 times 2. 2 times 1 is 2. 2 times 5 is 10, 102, right? Okay? What do I do if I multiply 5 and 1/10 times 2/10? I line them up, right? 2 times 1 is 2. 2 times 5 is 10. Then what do I do? How many? 2. 1 decimal place, but I need 2 decimal places after the decimal. I have to move it by how many I multiplied by. Okay? So what do you know? What is similar about those two numbers? Anybody see any similarities? Porter?
So if you just add a decimal point in between the 5 and the 1, and you add a 0 before the 2 and a decimal point between it, that's
Okay, so the only difference is the placement of the decimals, right? Did our result end up any different? Same numbers, it's just a difference in where the decimal places are, right? So what is similar, what is different? The numbers themselves are all the same. The place value is different. And that's really the only difference you're going to see. Oh, the place value, sorry. So the place value is different. But the actual numbers themselves are identical. When I multiply the same numbers, I get the same results. However, I have to take into account the place values when I look at my answer. Yes, Caden?
How would you know where to put the decimals?
What a great question. Let's see if I have an answer. Let's see. Steps to multiplying your decimals. How do I know? I'm going to add up the total amount of numbers behind the decimal point for all of the factors being multiplied. I'm going to write that number to the right of the numbers, and then I'm going to circle it. You're going to then multiply like normal. You basically pretend the decimals don't even exist. Don't forget about adding zeros for place value after you multiply each digit through completely. In other words, as I go from one level to the next, I start put 1 0 if I'm in the 10th place, 2 zeros if I'm in the 100th place, just like you normally would. Then use the number that you circled in step 1 to move the decimal point in your answer to the left that many places. So, Caden, there's your answer. Basically, once I've counted how many decimals I'm multiplying, once I get to my answer, I make sure my answer has that many decimal places. Then it'd be 2 decimal places. Then if I was multiplying by 2.1, that's another decimal place, so then my answer has to have 3 decimal places. Okay? And then check to make sure your answer logically makes sense. Ooh, I'm glad that's in there because it helps remind me. On the quiz, you guys killed me. Several of you. The whole word problems piece. That page, if I have 48 nails and I'm going to use 3/4 of them, could I use 64 nails? Yeah, you'd be shocked at the number of students who told me they used 64 of the 48 nails that they bought. The next question was, there's 24 muffins. How many of them are blueberry? Guess one of the most common answers? 36. There's 24 muffins, but 36 of them are blueberry. Does that make any sense? So here's something that a lot of times students don't realize. One big advantage to word problems is you can actually check to see if it makes sense. If I have 24 muffins and I get an answer that says 36 of them are blueberry, I probably made an error in my math.
Sounds pretty matrixy.
Okay? And there were a lot of people who made both of those errors that I just told you. Those were 2 of the most commonly missed questions for that reason. They didn't set them up properly. So guys, make sure when you're doing math, especially word problems, that your answer makes sense. So let's do a little bit of practice now. Okay? Now, I'll be honest. The reason we've given you these grids is some of you have atrocious handwriting, Ethan. So this allows you to really line your numbers up, because keeping your numbers organized is going to be critically important, especially when we're doing 3 numbers by 3 numbers. Okay? So let's do these examples together. Now, this one is written as 4 times 2 5/10. So does that mean I have to do the math like this? Do I have to do that? Okay? You guys want a little Mr. Moore math tip to make it easier for you? Put the least amount of digits on the bottom when I'm multiplying. Okay? I can rewrite this as 2 5/10 times 4. Now I'm only doing 1 digit on the bottom. So I do 4 times, how many decimal places do I have? 1. So I write a 1 here and I put a circle around it. That's my reminder that I need my 1 decimal place in my answer. Now I can pretend they're not even decimals. I'm just multiplying 25 times 4. So 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. Once I've done the math, now I put 1 decimal place in my answer. So my answer would be 10. Now, quick sidebar conversation. Which property of mathematics is it that says it doesn't matter if I do 4 times 25 or 2.5 times 4, I'm going to get the same answer? Oh, nice, Devin. You even said the entire thing correctly. Okay? So, I want everyone to add this to your notes. Commutative property of multiplication. And it is important to add which operation it is. We also have a commutative property of addition. We do not, however, have one for subtraction or division. If you mess up the order in division or subtraction, you get the wrong answer. Addition and multiplication, I can switch it. What this says is I can multiply in any order and get the same answer. That is a generic terms definition. That is not the official definition, but it's one written in language hopefully you guys understand. So commutative property of multiplication says it doesn't matter what order I multiply. I'm going to get the same answer. Okay? This allows it to make it a little bit simpler for you guys. So our next one, I have 3/10 times 3/10. Here's another Mr. Moore one. If I've got a 0 before the decimal, I don't actually need that. So I can just write 3/10 times 3/10. Count my decimal places. How many decimal places do I have? 2. So I write a 2 here with the circle, and I forget about them. Now I'm just multiplying 3 times 3. 3 times 3 is 9. Now here's the problem. How many decimal places do I need? 2. So what should I do? I have to put a 0 in front of the 9. Then put my decimal. Okay, don't put it after the 9. Put it in front of the 9. Big difference. So it's 9/100ths. It is not 9/10. Everybody good so far? Okay, our last one. And here's where we get a little more complex because we're looking at bigger numbers. Oh, geez. I finally got a hold of it, and then I let go. So 5 1/100ths times 1 600ths. We just follow our normal multiplication rules. First, count my decimals. 2 on the first one, 2 on the second one, so I have a total of how many? 4. So I do 4 here. At this point, I'm just multiplying 501 times 106. So 6 times 1 is 6. 6 times 0 is 0. 6 times 5 is 30. Put a 0 placeholder because I'm now moving to the next place over. It's all going to be zeros, so 3 more zeros. Now I'm doing the next one. I need 2 zeros. Then I can start the math. 1 times 1 is 1. 1 times 0 is 0. 1 times 5 is 5. So you can see the lines on the grid paper, the whole idea is to help you line your numbers up. Because I will tell you, if your handwriting is sloppy and you don't have good straight lines, there's a good chance you're going to make a silly error doing this. Now I just add up each of my columns. 6 with a bunch of zeros is 6. Bunch of zeros is 0. Zeros with 1 is 1. 3 and a couple zeros is 3. 5 and nothing else in it is a 5. Once I have all my numbers added up, now I put in my decimals. How many do I need? 4. So I start at the right. 1, 2, 3, 4, 5, and 3,106 10,000ths. Pretty simple, right? Now, just as a side note, for those of you that are a little better mathematically, technically I don't have to have that line there, guys. If it's a 0, all I can do is go to the next place and just make sure you added both of your zeros in. Make sense? Questions so far? Okay? Excuse me. Go to the next page. We're going to work one word problem together. Then we're going to set you guys free to get some work done on your own and make sure you're understanding how to do these. So our word problem, Courtney jogs 3 45/100ths miles each day to train for a half marathon she is running in January. In the month of July, she jogged 26 days. How far did Courtney jog in the month of July? So what kind of a problem is this going to be? Multiplication. Okay? I'm going to do it over here because I know some of you don't really like this. Grids. You can use it or not use it. If your handwriting is sloppy, highly recommend using the grids to keep yourself straight. If you have neat handwriting, like I do, then you don't necessarily need it. But just make sure you've got good handwriting. So I'm multiplying this by 26. How many decimal places do I have? Just 2. So I write my 2 up here. Now at this point, I'm just multiplying 345 times 26. So 6 times 5 is 30. 24 and 3 is 7. 6 times 3 is 18, plus 2 is 20. Put my placeholder, 2 times 5 is 10. 2 times 4 is 8, plus the 1 is 9. 2 times 3 is 6. Now I add up my columns, 0, 7, 9, 8. I need 2 decimal places. So it goes right in between the 9 and the 7. So she jogged 89 and 7/10 miles in July.
Dang.
That's some pretty good running right there. Any questions on anything we've covered so far, guys? Okay, so here's your chance. We have 5 more problems on this page that we want you to work by yourselves. Ms. McShannon and I will be coming around to help you out if you need some help with doing any of them. Number 1, this one should have been really simple. I'm going to do them on the side because I think it's harder for you guys to see if I do it on the actual grid. So again, we just line them up. 6/10 times 5. I have 1 decimal place. 6 times 5 is 30. 1 decimal place into the answer. 3 and 0/10. Number 2, going over. Again, even though it's written this way, I'm going to use the commutative property of multiplication. I'm going to go ahead and reverse that order so I have less digits on the bottom. So 1 and 35 hundredths times 2 and 7/10. And here's one, at least when I was helping my side, I'm seeing a lot of people that are still trying really hard to line up the decimals. You don't have to do that unless it's addition or subtraction, guys. When I'm multiplying, you just line up whatever the last number is. So I'm just counting my decimal places, 3 in this case, and then I'm multiplying 135 times 27. So 35, 21, 24, 9. Don't forget that 0 placeholder as well. I've seen several struggling about that, but when I move over to the next place, I'm now in the 10s. To signify that, I'm going to put the 10 there. 2 times 5 is 10, 6, 7, 2. Then just add up your columns. Once you're done with it all, now is where that 3 comes in. I put in 3 decimal places. 3 and 645 thousandths. Pretty good so far? Okay, good. Number 3, giraffe. It can run 46 and 93 hundredths per second. How far could it run in 1.8 seconds? So 46, 93 times 1 and 8/10. We got 3 decimal places. 72, 74, 48, 55, 32, 37. And then just the number, 3, 9, 6, 4. Add them all up, 4, 7, 14, 14, and 8. Put my 3 decimal places in, so it can run 484 and 474 thousandths feet. Okay, number 4, going on down still. The car can travel 28 and 45 hundredths miles with 1 gallon. The gas tank can hold 11 and 5/10. How many miles can this car travel? So I'm just going to multiply. Again, I'll put the one with less digits on the bottom. So 28 and 45 hundredths on the top. 11 and a half. Actually, let me redo that. 11 and a half on the bottom. Means I have 3 digits in my answer. 25, 22, 42, and 14. 0, then the number, 5482. Then 2 zeros in the number, 5482. Add up all my columns. I have a 5, I have a 7, 9, 10, 11, 16, 17, 10, 12, and 3. I put 3 digits in my answer, so 327 and 175th miles. And our last one was a little more complex because there's multi-parts to it. That's what I actually kind of like, because we're not only multiplying, we're also adding. So we've got the pears at 92 cents a pound, and apples at $1.10 a pound. He bought 3 7/75 of pears and 2 1/10 of apples. So how much did he pay for all of it? So we're going to start with the pears. I had 3 7/75 at 92 cents a pound. So I've got 4 decimal places. 10, 14, 15, 6, 7. Then I have a 0, 45, 63, 67, 27, 33. Gives us 0, 10, 15. That was 33, right? 6, and 6 was 12. Oh, there I was, 27, 33, okay. When the smartboard erases my numbers, it makes it a little bit harder. So that gives me 4 decimal places, so I spent $3.35. Oh, that wasn't you.
What did I do?
I don't know, my smartboard just disappeared.
Wasn't me, not here.
It crashed. So the smartboard crashed. We were at $3.35 for the pears. Am I remembering that correctly? So I do the apples next. That's $1.10 and 2 1/10. So I've got 3 decimal places. Gives me a 0, 1, 1, 0, 0, 2, 2. Gives me 0, 1, 3, 2. 3 decimal places. I take my $2.31 that I spent for the apples, add it to the $3.35 for the pears, and I end up with $5.66. Is that correct, guys? Is that what you got? $5.66, or did you guys get something different?
Well, for the pears, I got $3.45. Yeah, I thought it was.
Is that what I got?
76.
Okay. Yeah, that's what happened when it erased. $5.76. Sound good?
Yes.
Good. Okay, next up. Last page is your homework, guys. Again, I'm multiplying all the decimals. If you want it, the very back sheet is entirely a grid paper for you to line up your decimals. You are not required to use it unless you want to. But for those of you that kind of like having that grid paper to keep your work straight, use it. Other than that, there should be enough room on this to go ahead and do all of those. You only got the 11 problems, and then the 5, because you're only doing A through E on number 1 for the page 42 in your books. Page 42 in your books, you're doing number 1, problems A through E. So you don't have to do all of them. Any questions on anything we covered today? Okay.